Okay, we're going to get started. Welcome everybody to the first Clinux Intermediate Training webinar. We're going to today learn how to do multi-unit case design. We're going to look at mastering copy and database crown designs. We're going to do a deep dive on design parameters, case parameters, and preferences. And of course, you can ask questions throughout the presentation in the Q&A that is in your control. So you can just click on Q&A. And in fact, you can post your questions anonymously if you prefer. So let's go ahead and get started, shall we? Okay, there we go. This is me. My name is Roddy McLeod. I am the CEO of Cadre Manufacturing GmbH here in Germany. This is where we make the Clinux CAD software for Cadre, and myself, as well as our team over here, our head of R&D, Mr. Ulf Willers. We're both of us more than 20 years involved in chairside CAD/CAM. And both of us started with the CEREC system many, many years ago. Ulf and I worked together starting from 2003. And we introduced the CEREC 3D software, and we've been basically working together over the years since that time. So we've got a bit of background here in the space. And today, what we want to do, as I mentioned, is make sure that you get the most out of your Clinux subscription. This is the whole idea of this training. Actually, our goal for this training is that you just become more comfortable in your day-to-day work with Clinux. I'm going to show you some new applications. I'm going to show you some tips and tricks, and we're going to understand the software a little bit better. But as I mentioned, the whole idea here is that your day-to-day Clinux work becomes very simple and routine for you, and you know exactly what you want to do and when. So this is the whole idea. So let's go ahead and get started with multi-unit crown design. So I'm going to flip over now to Clinux, and I've got Google Chrome open here, and here I am in the Clinux dashboard. And what we want to do is multi-unit design. And I've got a nice case here. There's 2 units on the lower arch, and we're going to start with these guys. So anytime you want to, by the way, check what scans are in your case, you can just click on this magnifying glass on the upper right, and this will give you a blown up view of the scans in the case. So here I can see on the mandible, there's 2 crowns, and I have my maxillary. So I'm just going to go ahead and start that case just by clicking on it, and that opens the case for me. And once we get in there, we're going to show you the basics of multi-unit design. It's incredibly simple and straightforward in the Clinux software, and this is the main feature right here. You see that both teeth are already set up and ready to be worked on. So let's go to our settings tab here and go to case information and see how this case is set up, shall we? So we've got some scans, as I've mentioned. We've got our lower mandible with the preps, and we have our maxillary scan. And then when it comes to indication, this is a prosthetic, obviously. We're making 2 crowns on tooth number 3.6 and 3.7 in the FDI tooth numbering system. And you see that tooth 3.6 is set up for a database crown, as is tooth 3.7. And one thing I want to show you here is a little bit about the admin of this. Let's say we had a 3rd tooth, okay? Then what you do to set that up is you just select the tooth. Let's say it's the premolar 3.5, and then you can choose whether or not you want to do this with database or copy. You see that copy is grayed out for me here, and the reason for that is because I don't have a preoperative scan. So my only choice here is to start from scratch and do it as a database, okay? But when that tooth is selected, I can also go over here and delete it from the prescription. Okay, so that's basically how you move around the prescription form here. Sorry, and I want to start working on tooth number 3.6. So I've selected that one, and now I click on confirm, and Clinux will set me up to work on tooth number 3.6. I'm going to put this guy back down at the bottom. And here's our lower arch, as I mentioned. There's the upper arch. Got a nice set of scans here from the clinician. And the bite is really evenly distributed here around the arch. I like this. This looks really good. Okay, nice case. And let's go ahead and get started, shall we? So on 3-7, you see that the margin is already drawn. I am on step 1, preparation margin, draw preparation margin, and I'm on tooth number 3-6. And this is important. You make sure that you are on the tooth selected before you start working, okay? So go ahead and choose tooth number 3-6, and then I'm gonna show you how to draw a margin here in Clinux, okay? And if you have, in your CAD Assistant, if you have the tips turned on, then you can see, for example, that beside my cursor, Clinux is giving me a tip on how to get started drawing my margin. So I usually leave those tips on because it just makes life pretty simple. And so now what I want to do is I want to start my margin. So I look for a very sharp edge on the margin somewhere like this guy right here. With a double click, I make my first start of the margin, and then with single left clicks, I'm now going around the margin, and every few, I don't know, millimeters or so, or less, I'm making single left clicks to lock that margin down onto the tooth, as you see here. And so you'll also notice I'm rotating the model a little bit. Don't be afraid to do that. You can zoom in and zoom out while you have the tool active. You see, there's my margin tool. I can zoom in and I can zoom out. I can also rotate the model like so. Yeah. And if your margin goes all over the place, don't worry about it. Just right click once or twice, and then he comes back, okay? And so I like to rotate the model because I want to look at this margin from this view that I have right now, which is more or less of a 45-degree view on the margin. So that's so that they don't go off the margin. See, if you have a perfect up and down view, okay, when you're drawing the margin, it's very easy to go over the margin. I'm just going to show you that here, what that looks like when you go over the margin. You get these little guys down here, okay, where you see the margin drops down like this. You know, typically, and to be honest with you, most of this stuff won't even survive the milling or the printing process. But you may want to have that stuff cleaned up before you go ahead and process your case, okay? Here I went a little bit over as well. Bring that guy back up, something like this. Okay. So that's looking pretty good. I go all the way around the margin, make sure it's all set up correct here. Yeah, it's all okay. Good. So I've got my margin. And once I've drawn that margin, I can just go ahead and click on next, as you know. And we'll come to our next step, which is our insertion axis. And what's important there at the insertion axis, of course, this one. Please ensure the mesial points to the right. Well, here's our mesial tooth. It's the premolar, right? And that's now pointing to the left of our preparation. So we've got to get this guy over to the other side. And the quickest, easiest, fastest way to do this is this guy right here, this axis tools, rotate, mesio-distal axis. Watch this. I click on this button once, and the model flips 180 degrees around our tooth, and now puts the mesial tooth here on my right as Clinux wants. So once that's there on the right, the rest, you just set up the insertion axis as you would expect the crown to go down. And once you've done that, you click on next. Okay. And what we see now is, let's say, the initial crown proposal, or positioning, I should say. It's not a proposal yet. It's not attached to the margin. It's the initial positioning of the crown. Needs work, doesn't it? Let's go ahead and do that. I'm going to rotate this guy first of all, so he's tipped distally. I'm going to move him mesially until he's basically got some contact there with the mesial neighbor. Let's zoom in a little bit. Can you see that? Let's back that out a little bit. So I just want to have just a little bit of contact with the mesial neighbor. So something like this is good. And then I'm checking whether or not this crown is too big or too small, especially here on the distal, because don't forget, I'm going to have to make a crown here on 237. And now I have to kind of envision where that crown is going to come out, like the proximal embrasure, for example. That crown has to come up and meet this crown here that I'm working on. It looks like I've got enough space there. That actually looks pretty good. And so that's about it. I think the crown, aside from this, is just a little bit too high. I might bring it down just slightly, something like this. And don't worry too much about this red. We can sort that out with the tools. Let's go ahead and click on next. And what Clinux does now, obviously, is cut the crown shell where it's too long and attaches it now to the margins that we've drawn, and builds the proximal contact and all the rest of it. Okay. So here we are, and we're on step 4, restore, adjust first contact. So Clinux always puts you on that first contact. That's what we're looking at here. We're looking at the first contact from, from a view that allows you to adjust it immediately. Our idea is that you get through this, our software, as quickly as possible. Now, as you know, there's many ways to build contacts. You can use the form tool, or you can use the circular shape tool. It really depends on your own preference. Give them both a try. They work totally differently, right? So the form add is literally just adding material underneath this orange preview that you see here, this orange circle that's around my cursor. That is the size of the affected area when I activate the form tool. Now, I don't want red in the middle, so I'm just going to polish that back until I've got some yellow. As I mentioned in the weekly training, you should try milling or printing a couple of these to see what is the right level of contact for you and for your system. Now we're looking at adjust second contact. There is no second contact yet on the distal. Just go ahead and click on next, and Clinux will show us now the occlusal contacts. Now here's where I like to use the circular shape tool. I've got all this red. If I mill or print this crown as it is right now, it's going to be way too high in the mouth and require a lot of adjustment. So I'm going to grab my circular shape tool, and I'm going to put it right over the center of this red spot here, and I'm going to drag this down until the contact is nice and light, like so. That's looking pretty good. I'm going to do the same thing here on this distal buccal cusp. Same thing, drag that guy down, and same thing here in the middle with this the occlusion, and there we go. Actually, it's not too bad. Now, to take out these little red spots, typically what I do is I just grab the subtract tool now and make a few clicks in there. And that's just pushing back that surface a little bit. You see how that works there? And so just with a couple clicks and without really editing or destroying the anatomical form of the tooth, I've been able to reduce the contacts to a manageable level where it may just need a little bit of polishing in the mouth. So something like this looks okay. And so we've got our first crown done. And so now it's time to design the second one. And in order to design the second crown, I literally just click on 237. You see that the 236 is now deactivated, and we're now active on 237. And the margin has already been drawn on 237. So I'm just going to go ahead and click on next. And now we have our insertion axis step. The mesial tooth is pointing to the right, so that looks fine. I'm going to click on next again. And we come again to the position your crown step. So I've got a position here, actually not too bad, right out of the gate. Maybe a little bit too lingual. Let's just move this guy maybe a little bit like so, and then maybe up as well. Okay, so something like this. I like to see some contacts on the occlusion. I'm always worried that I'm too thin. And so when I'm in this positioning step, I like to have a little bit of red in the contacts because I can always bring the cusps or the marginal ridges down. But it's more difficult to do the other way around, which is to bring the fissure up, so to say. So you can start with the cusps a little bit high and then use your circular shape tool to bring those down in your next step. So let's just go ahead and click on next, and we'll get our crown proposal. And we'll work on these high spots, okay? While we're waiting, are there any questions yet? Okay, so nothing in the Q&A. As I said, you can start with the Q&A whenever you like. If you have questions as we go along here. Now I've got, okay, so now I've got my proximal contact, which is huge, way, way, way too big. And so this one has to be peeled back. And it's so big that using, for example, the form subtract, let's just go ahead and do some of that, okay? We take the form subtract in there. I just want to show you, you know, what kind of an effect that's going to produce, okay? So it's okay, but what's going to happen here is that we're going to get a little concavity here in the proximal surface because only the middle is going down, or let's say the middle part of that red spot is going down more than the rest. And so we're going to get a concavity there, and that's not going to look quite right. So I'm just going to undo that by clicking on undo. And I'm going to, let's see, sure we get all the way there. How many undos do we need? Yeah. I think we're there now. Yes, okay, good. So that's where we started from. So now I'm going to grab the circular shape instead of the subtract. Because look at the size of the surface, right? So it's a big surface, and I have to move the whole thing back, and I don't want it to look like a potato. I don't want strange concavities or something like that. So I'm grabbing the circular shape. I've made the circular shape like the size of half of the tooth or so. And now I'm going to grab the center of that red spot, and I'm going to push it back. You see, and now the cusps and the marginal ridges are moving back as well. And so I'm not going to get a strange shaped tooth here when I'm done my editing. So there I've got a nice contact surface there. You can see I pulled in here at the gingiva a little bit. Watch how I fix this. So I'm going to go in with the smooth tool, believe it or not. Bring this guy down a little bit, something like this. And you can see this little deformation that happened here near the margin. I'm just going to put the smooth tool on this, and this relaxes that surface and actually brings that concavity out. And you'll see that here in a second. So yeah, you see that? So now I've smoothed that all out, and so that's going to be easy to clean for the patient. No worries, no issues there. Okay, so our proximal contact is done. We click on next. It's going to show us the distal contact. There is no contact here. It's the terminal tooth. And now I click on next again, and I come to the occlusal contacts. There we are. We've just got a couple of high spots. I'm going to click on the subtract tool here just to tap those guys down, something like this, okay? And that's basically it. And the other thing I want to mention to you is that as you go through the steps with each tooth, like here I'm on step 4, so it shows step 4, yeah, and you see the full orange circle. If I go back one step, select crown, this will go back to step 3. You see that? So you always know what step you're on each tooth. So you can imagine if you had, like, I don't know, 6 or 8 teeth here in a row, this is a very helpful thing. It tells you how far along you've gotten with each one of your teeth in the arch, okay? And so that's basically it. Last step is going to be export for print. And what's really nice here is that we can export both crowns at the same time. And in fact, you can also determine the quantity of the crowns that you want to have. You may want to print 2 copies of these crowns, maybe not these ones because they're in the posterior, but let's assume you're doing an anterior case and you want to play around with some stain and glaze. This is a perfect thing, yeah? So you can set up, so you can print 2 or 3 of these crowns, and you can, as I said, experiment with your stain and glaze, because printing an extra crown costs you, I don't know, maybe another $2 or something like this. So it's kind of worth to play around there a little bit, and nice little feature inside Clinux to allow you to do that. So that is an introduction, I would say, to multi-unit design. And my suggestion to you, doctor, is if you're watching this webinar, don't start with, 6 anteriors as your first multi-unit case. Anteriors are always more difficult than posteriors. Do yourself a favor, do a couple, 2 or 3 in the posterior first time you do the multi-unit until you get a little bit comfortable with the workflow. This would be my suggestion personally, okay? I'm gonna come back to the Clinux dashboard, and I'm gonna switch also back to our training because our next topic is mastering copy and database crown design. So let's just take a quick look at that. So inside the Clinux software, we have two ways to make crowns. One of them is using the so-called copy method. That's what you see here up in the top. We're going to show you this here in a second. And the other one is database, which we just saw now. And there's a couple of tips and tricks here, okay? So first of all, when it comes to copy crowns, the trick to the copy crown is that it's all about the copy line. That is step 3. And I'm going to show you this live, so we're going to take a look at this in the software, but just to get these concepts into your mind, okay? So first step is, when it comes to copy crowns, it's all about the copy line. That's the most important piece of designing your copy crown. Second thing is, ensure that your copy line is drawn correctly. I'm going to show you how to do that here in a few seconds. Make any edits as you see fit, and definitely avoid drawing the copy line over bad data, so-called bad data. So let's go ahead and just take a look at a copy crown case here inside Clinux. We're going to go back to this premolar case, and so we've got our we're on the step preparation margin, and I'm going to click on next. And of course, we have our insertion axis. I'm going to skip past that one as well. And I'm going to come to, and you see this now, step 3, copy line. But you'll notice that the CAD assistant still says loading. And the reason it's still loading is because Clinux automatically skips you over this copy line, and we're going to land now at restore. You see that? So we've just landed at restore, adjust first contact. Clinux has put you onto the first contact, just like always. There's our copy crown. But let me go back one step. And so this is something I recommend you do every time you do a copy case. Go ahead and let Clinux propose your crown, as I did now. But once it's been proposed, go back to the copy line and see what Clinux did, okay? So what am I looking at? I'm looking at our pre-op scan, right? So this is the scan the doctor made before preparing the tooth, okay? And this scan is used by Clinux to draw this copy line. So we've drawn this line here all the way around the tooth for you, and we did it automatically, okay? And our idea is that we want to use as much of this tooth as we can for your new crown. And in this case, the copy line is drawn correctly, okay? But you can also edit that copy line. Let's say for whatever reason, yeah, we didn't want to copy this marginal ridge and we wanted to build it by hand in the Clinux software. I can redraw this copy line now so that I'm excluding this marginal ridge. You see that? And now let's go ahead and click on next and see what Clinux gives us. As usual, Clinux puts us on to adjust first contact. Let's just rotate the model and take a look. Oh yeah, okay. So now let's bring up our pre-op scan, shall we? There's our pre-op scan. And now when I fade it out, you can see the new crown is missing this marginal ridge information, isn't it? And that's because we redrew that copy line. Let's go back to the copy line step. There's the redrawn copy line. Now I'm going to bring it back to more like how Clinux made it originally. And so I'm going to come here really close now to the neighbor, but not touching the neighbor. Make sure you don't touch the neighbor when you redraw these copy lines. Keep it on your destination tooth. There, I've redrawn the copy line. You can see it there. Now it includes that marginal ridge. I'm going to go ahead and click on next. And of course, Clinux is now using the new information from the copy line that I just drew to create the marginal ridge. Yeah. So there you see, I've got a proximal contact, everything good. So as I mentioned, the key to copy crowns is this copy line step. Make sure that you get comfortable with this one. Do what I just did, actually. Grab a case with a pre-op and play around with drawing that copy line in different ways. And then you will see how Clinux handles that, and you'll have a much better feel for how that works. Now I want to show you some database. So let's go back to the presentation real quick. That was our copy line. Here's the database crowns. And the secret to database crowns is it's all about the select your crown and confirm or edit placement. Again, step 3 in the process, okay? And when you get it, when you come to this step where you have to do the positioning and rotating, scaling, and so on, don't spend a lot of time there. Spend about a minute. If you're spending more than a minute there, you're spending too much time, okay? Then certainly don't spend 5 minutes there. You want to get it close, but you don't have to get it perfect. When you do that positioning, make sure that you've got a little bit of contact with the neighbor before you click on next, so that you get a proximal contact proposal. And then also don't forget to try the different libraries to see which tooth fits better. I'll show you that here in a second. And last but not least, and this is a really cool tip, if you have a pre-op, even if it's been broken down or crushed or whatever, go ahead and keep your pre-op in your case, because you can turn that on while you're doing this positioning step, and that'll guide you quite a bit in the positioning of your crown. And let me show you how that works. Okay, let's come back to Clinux. I'm going to now go back to the prescription form, and I'm going to switch tooth number 15 from copy to database, and I'm going to click on confirm. And of course, Clinux deletes the copy crown that I just made, brings me back to the preparation margin. I'm going to go ahead and click on next here in a second. I just have to make a small change to the margin. In a second. There we go. Click on next, and we have our insertion axis step that's been unchanged since I did it the first time. And we click on, and now comes, sorry, the crown shell for positioning, right? There it is, unattached to the margin. So the last thing I just mentioned was go ahead and turn on the pre-op if you have it. So here's our pre-op, you see? There's our pre-op. I can see it there. And I can see my new crown. So actually I can use this pre-op as a guide to position my new crown, can I? So look, there's probably the right mesial distal. And if I look now from this angle, I can see that the lingual cusp is too high, the buccal cusp too low. So let's just go ahead and set those. And if I lower that, you see, now you see the height of my database crown, okay, is essentially identical with that of the height of the preoperative crown. And I could even scale this back to make it even closer to the pre-op, and I can lift it up here again. You see that? So now, and again, this is the benefit of keeping that pre-op or having a pre-op, is that you can always check and see, hey, how well does the new database, you know, fit to the prior occlusion? And so, for example, if I look to the fissure, I can see my new crown is well underneath the fissure of the old tooth. So I can still lift this up like so. And then I can bring these cusps back down again in the next step if I want to do that. Okay. So these are just some design tips for you. I've got a small light contact here on the proximal surface. This thing's ready to go. I just click on next now, and you'll see we'll get a database tooth that's going to fit into this clinical situation quite well. So there we go. And puts us on the distal again. There's our database tooth. Okay. And now I'm going to turn on the pre-op. There it is. And so, for example, what about this cusp? So I'm going to take the circular shape tool. I'm going to make it big so that I grab that whole lingual surface essentially. And now I can drag that cusp exactly where it was in the pre-op. You see that? Now this guy's a little too fat down here, so we can give him a diet. Look at that. And now I can always also see the previous lingual surface of the preoperative tooth. And so now that whole lingual is almost identical to the pre-op situation. So, and you know, you can play with this all you want, and just back that in. See, there's the pre-op. And so as I drag this guy out, he starts to come over top of the pre-op. So like I said, it's a great guide for positioning and setting up your crown in this case, okay? And also very helpful for anteriors. So if you're doing a whole bunch of anteriors or something like that, make sure you grab that pre-op. It just saves you so much time in setting up the positioning of your database crown or something like that. Very good. So let's come back to our presentation. As I mentioned, use a pre-op to help with that positioning. Oh, and try the different libraries. I didn't do that. Let's just go back, select your crown, step 3. Let's go back. So I did the positioning. That was, however, the crown library option 1. Here's option 2. I just click on option 2 and Clinux shows it to me. Same thing again. Okay, there's option 2. Let's go ahead and turn on, whoop, not that guy, the pre-op. See? And I can lift that guy up. And I can see that he's also too big. So I can just get you bigger so you guys can see it. There. And now scale this crown back. You see? There's about the size of the crown. Probably needs a bit of rotation there. Definitely needs to go up. Needs to go measly. And look at that. I'm almost a perfect copy of the preoperative condition already with just a few clicks. You see? So this is going to reduce your amount of adjustment time, your overall design time in Clinux, and get you in and out of the software a lot faster. And that's the whole idea. We don't want you to spend a lot of time in Clinux. You should be in Clinux for 4, 5, 6 minutes, 7 minutes max, and then you should be out. And if you're taking longer than this, yeah, practice. This is the whole thing. You know, the more you do stuff, the better you get at it. And if you only use Clinux once a week, you're probably never going to get too good at it. If you use Clinux once a day, however, you're going to become an expert within a very short period of time. So there we go. These were the tips on designing your database crowns. Let's go ahead. That was that, mastering the copy and database crowns. And now let's look to your design parameters, and something else called case parameters, and then finally preferences. And we'll see what the differences are here in all of these. Okay, so here we go with understanding parameters. How do you get to your design parameters? Well, once you're inside Clinux and on the dashboard, then you can click on your initials in the upper right corner. Click on that, and then a little menu pops up, and then you can click on parameters as your second step. And that brings you to this view right here. And now it's important to understand that in parameters, we have parameters for prosthetics as well as splints. And you'll be set up on prosthetics first. And so then the first thing you see is, for example, proximal contact strength. And your options are light, medium, and heavy. So let's take a look at that. When you have your proximal contact strength set on light, then Clinux will try to give you a proximal contact like you see here without any yellow and just a little bit of green. If you have your proximal contact strength set to medium, as I do, Clinux always tries to give you a little bit of yellow. And if you set them to heavy, Clinux will try to give you some red. And of course, it matters. So for example, if you're doing a database crown, okay? If you're doing a database crown, it really matters where you position that crown shell. If your crown shell is not touching the neighbor, it could be that Clinux does not propose any proximal contact to you, and you're going to have to build that surface out to build a proximal contact. That's why I suggest in the positioning step with database, always make sure you have a light contact to the neighbor, and you'll get a proximal contact proposal from Clinux. Let's just check. Do we have any questions yet? No, still no questions. All right, let's continue. That was proximal contact strength. The next one is minimal thickness body. And our minimal thickness body can be pre-configured in 2 directions, occlusally and as also radially. And so let's take a look at that here. I have mine set up for 1 millimeter occlusally and 0.7 millimeters radially. And yeah, so if you're in Clinux and you're designing a crown, you can go ahead and turn on the minimal thickness body. This is in your tools panel, and it's just a little on-off switch. And when you have it on, then Clinux will show you this blue semi-transparent shell over the crown preparation. And it will do so in the a shape that you have configured in your parameter. So for example, I have my occlusal thickness set to 1 millimeter, and that's what you see here, and radial thickness set to 0.7, and that's what you see here all along the axis. Next, for crowns, we have spacer, and this is really cement spacer. And the default setting is at 100 microns, and I have to be honest with you, we have not heard about too many fit issues. So it seems like a very good default setting, but it is adjustable. So if you find your crowns are too loose, you can bring your spacer down, for example, all the way to 0. Okay, and then this is what the surface is going to look like. Or if your crowns are too tight, then you can increase your spacer to a maximum of 250 microns. And it's not so easy to see the difference between these two intaglios here, but if you look to these red circles, here you can see there's certainly more material here in the intaglio than what we see here on the right-hand side. Very good. Let's continue. Next parameter we have is margin thickness, and this is for all of you who are milling out there. Margin thickness is designed for you, and why is because if you're milling and you have some experience with milling, you know that certain materials, Emax comes to mind, zirconia is another one, that are prone to chipping during the milling process, and of course the thinnest areas are going to chip first, aren't they? And the thinnest areas are typically around your margins. So a margin thickness of 30 microns, which is the lowest setting in our software, produces a margin which essentially comes flush to the actual margin line and to the tooth preparation. And if you set your margin thickness to the max, which is 120 microns, you see that we add material here on the margin, and that whole idea behind that is that you're going to polish that back, and the margin will be robust enough to survive the milling process. Okay, so if you find that you have chipping or this or that, make sure that you build out those that margin thickness a little bit and see if that doesn't solve the situation for you. This is only a topic for milling. This has no effect at all on printed restorations. We don't have this problem with printed restorations. Last but not least, also a milling only topic, which is burr diameter. And specifically what we're talking about here is the burr that mills the intaglio or the internal fitting surface of your crown. So for example, you need to know, if you have a milling unit, you need to know what is the diameter of this right here. What is the diameter of the tip of the milling burr that mills the inside of the crown? And with this diameter, 1 millimeter or 500 microns or 1.5 millimeters, whatever it is, you need to know what it is in your milling unit, and you need to set that parameter here in Clinux. So so for example, you can see the difference. Okay, so when you have a very, very, very small intaglio milling burr, 0.5 millimeter, for example, you see almost no overmilling of any kind in the intaglio. And then when you have a larger burr, or if your mill requires a larger burr, like 1 millimeter or 1.5, then you're going to see these circles, and these circles are a representation of the top of this burr. Okay, so we run a complete milling simulation program on the intaglio of your crowns, and this is what we send over to your CAM software. Okay, so it's already prepared and ready for milling. Now, once you're in those parameters over here, you saw that we start on prosthetics, but you can also click on splints. And so this is for your night guards and for your splints, and you can set up how thick should the night guard be. So for example, you can set the occlusal thickness. I have mine set at 3 millimeters. You can set yours at whatever you like. Then you have night guard thickness radial. So this is obviously the radial thickness of the guard. I have mine set at 1.5. And let's just take a look how that looks like. So here's the night guard inside Clinux. Turn the model off so you just see the night guard itself. So there's the 3 millimeters occlusally, and we have 1.5 here on the radial surfaces. Okay. Next is something called flatness, and I think we have to actually change the wording here a little bit because it's a little confusing, but flatness refers to how much anatomical detail there is in your night guard. So basically, if you set your flatness to light, you're going to get essentially an anatomical night guard from Clinux, which you can still use your tools. You can use the form, add, smooth, subtract. You can use the circular shape. You can change any of the surfaces. It's not an issue. It's just the initial proposal will come out with a lot of anatomical detail. If you set your flatness to heavy, for example, then you're going to get what we call our flat plane night guard. Okay, so without any anatomical feature of any kind, and you can go on and work on that with your tools. Last but not least, there's also a spacer setting for your night guards, and this is not about cement. This is more about the snugness of the fit of your night guards. Again, we find that the 0 micron setting seems to work for our customers. We have not had night guard fitting issues, but in beta testing, we did have one doctor who had a printer from an exotic manufacturer, and all of his night guards came out too loose. And so we adjusted the spacer settings so that you can actually set it up to -50 microns, so really kind of a negative. And if you find that they're too loose, or if you find that they're too tight, you can go in the other direction, into the positive direction. You can go to +50 microns, okay? And within that 100 micron space, you should be able to fine tune the fits of your night guards without any trouble. Again, start with the default setting and then just check, are they generally loose? If so, go to the negative on the spacer. If they're generally tight, go to the positive on the spacer. Now, that's the parameters for the Clinux software. And those are the general, what we call the general parameters. However, while you're in a case, if for some reason you want to adjust the parameters on that crown or that case only, then you can come up here and click on the little settings button, and then click on case parameters. And what's going to happen is we get now a window that slides out from the left. And these are the case parameters. So these parameters here only affect the case that you're working on right now, and it will not affect your general parameters. So if for whatever reason, normally you set up your night guards at 3,000 or 3 millimeters in occlusal thickness, but this one you only want as 2 millimeters, you can go ahead and change it to 2 millimeters here, click confirm, and then only this night guard will be 2 millimeters thick, and subsequent night guards will go back to the 3 millimeter thickness, if it makes sense. Okay, so your case parameters, as a summary, only affect the case that you're working on right now. They do not change or affect in any way the general parameters. So as I say, you would use this only when, for whatever reason, this case needs a specific tweak on the spacer, or you want a flat plane night guard instead of an anatomical night guard or something like that, or you want to change the occlusal or radial thicknesses, all right? So that's when you would use the case parameters. And so, for example, that one is on the night guard. Here is the case parameter for a single crown. And here you can see, you can already set the proximal contact strength. You have the minimal thickness body settings. You have the spacer setting, margin thickness, burr diameter. And when you open the case parameters for the first time, these will be an exact copy of your general parameters. And again, only if you want to change something specific for this crown, then you want to play with these case parameters. And now I'm going to come to the next one, which is a multi-unit case parameter. And what's super cool about this is, especially for multi-units, is you can now apply your case parameters to all the teeth or to selected teeth. So you can be very quick in your editing. If you have to change the spacer on all of them, or if you have to change the margin thickness on all of them, you can simply click apply to all. And then all of the units in your multi-unit case will receive those edits from the case parameters. Good. And last but not least, we have preferences inside the Clinux software. And again, from the dashboard, you can click on your initials and then click on preferences. And when you get in there, you're going to see two types of preferences. You have general preferences, and you also have integrations. We'll get through these in 1 second. So first, we're going to start with general. And then, of course, as you probably already know, you have to set up your case folder on your hard drive. Then you have your manufacturing options. If you have a mill and a printer, one of these has to be selected or both. So that's up to you and what you have there at your practice. Dental notation, of course, is you can switch between the International FDI or the ADA tooth numbering system as you prefer. And then mouse behavior, if you're not aware, you can set up which button will rotate the model. So for example, if you like that the left mouse click rotates the model as I do, then choose this one. And if you like it that the right mouse button rotates the model, then choose the bottom one. Now when we come to integrations, so I can just click on integrations, and you'll see that here is where you can integrate with various milling cams and 3D printer softwares. Now, I made this screenshot on my Mac because if you're on a Mac, then this feature is not available to you. We have a small program called Clinux Bridge that runs in the taskbar, and this is a Windows-only feature at this time. Now, let's go ahead and take a look at that, though, and just by going into the software and look at our integration. So I'm going to come back to the dashboard. And I'm going to click on my profile, and I'm going to click on preferences. And now I'm going to click on integrations. And you can see that I have 4 integrations enabled. I have Accurata Alpha 3D. This is enabled. I have Chitubox. This is enabled. I have EnvisionTech enabled, and I have SprintRay Wayware. Why do I have these ones and not the milling cams? That's pretty simple. All the 3D softwares are free, and you can download them at any time, as I did. Yeah, but all the cam softwares you have to pay for, and I don't have a demo license on these ones or anything like that. Clinux Bridge. Let's talk about Clinux Bridge for a second. So it runs in your taskbar. So I've got it running here in the taskbar. So if you're on a Windows system, you just go down to your taskbar, open up the taskbar applications that are running. There's one called Clinux Bridge. Just left click on that once, and that opens up Clinux Bridge. And it'll show you the Clinux Bridge version number. This is 135. This is the current one. It shows me where my case folder is set, and it shows me what softwares I have integrated. So again, here are the milling integrations. So these are milling cam softwares. There's GoToCam, Dentsply Sirona InLab, SimSystems Mailbox. And again, I don't have any connections there because I simply don't have the software installed on my computer. I do have the 3D softwares installed, and that's why they all show up green. Now, there's something important I want to share with you. If you have any of these softwares, it includes the milling cam softwares up top here, also includes the 3D printing softwares down here. If you have these softwares installed in the standard installation folders, that means when you install, for example, Accurata Alpha 3D or SprintRay Wayware, and you click on the install steps in the installation wizard, and you click next, 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 and you don't change the install path, Clinux will find these installations for you automatically. We're already looking in C, Alpha 3D, bin, alpha3d.exe. We're looking for that file. So if it's a standard installation, you don't even need to click on change and find Alpha 3D. No, it's already there. We find it for you automatically. However, if you do have Accurata's Alpha 3D installed somewhere else, then you're going to have to go navigate and find that installation and keep going until you find this file here, which is the exe file. Okay, that's what's going to start the application. So that's the file that you need to select here. Same thing for SprintRay, which is the standard installation is C, program files, Rayware, Okay, and then when you scroll down, you're going to find this Rayware exe file. You click on open or click OK, and that's the path to Rayware. Once that's set up and they're green, that means that as soon as we have a crown, let's see if we can do this quick. Get this guy open, see if we can go to export. Export for print. Now I'm in printing, right? So milling, I don't have anything set up in milling, right? So I just clicked on the milling tab here. I don't have anything. So it's going to send everything to the case folder automatically. Okay. But under printing, I've got options, right? So I can click on the drop down menu. I can send it to the case folder. I can send it to Accurata or Chitubox, EnvisionTech, or Rayware, whatever. And the beauty of having this all set up like this is once I click on export, and I've chosen, for example, Rayware, Clinux will automatically export the crown to Rayware, and it'll also automatically write the exported STL file of the crown to the cases folder. And if I want to see the cases folder, I just click on here, open folder. I find this really convenient because if you're in the drag and drop mode of living, then this is a very quick and easy way. And your printed crown is going to be this guy, and we even call it that. So there's the STL, sample number 1, upper right premolar, 15, printed 1 crown STL. And so from there, I can do whatever I need to do. Now, so then the other thing is Rayware opened up in the background, didn't it? And loaded my crown onto the build plate. There it is. And so I'm ready to go ahead and send this guy off to my Sprint Ray printer. Well, it's been a long day. I'm going to close that guy and let's come back to our presentation. Okay. Were there any questions so far? No questions. So I guess it's all clear. Let's keep going and plow through here. So that was the integrations. Yeah, we have a Q&A time now. Any of you who'd like to ask your questions, either anonymously or with your name, you can do it either way. Andrew Ip, I cannot believe you're here. So we have one of our trainers, one of our Clinux trainers, Dr. Andrew Ip from Australia. He's on the call. It's now, what is it now, Andrew? It's like 5 minutes to 1 a.m. So it's well after midnight in Australia, but he's hanging in there. Good to see you there. Thanks for joining, Andrew, and good luck in Hawaii next week as well. Well, look, folks, if there are no questions, then let's go ahead and cover just the last couple of points here. So that was our first Clinux Intermediate training. We're going to do them every Friday, every last Friday of the month. So our next intermediate training is coming up on the 28th of July, 2023. You can register or find the way to register for the event on our Clinux user group in Facebook. So if you are on Facebook, make sure you join our Clinux user group. We're posting obviously training, but also tips and tricks and cases and all this kind of stuff. We do have a question here. Question is, what's the best way to build up connectors? I would ask, Doctor, that maybe you clarify that question a little bit. Connectors between what exactly? That would help me. I want to make sure that I answer your question correctly. So while he's typing maybe that question in, I just want to point out that we have another question here. 1 second. Question is, how concerned should I be in terms of the algorithm of Clinux to CAM software like InLab? I've only designed and milled in Sarek chairside. What troubleshooting should I expect? Okay, very good. So Doctor, generally speaking, we've tested this quite a bit. Dr. Jonathan Acker in the United States, he has the InLab CAM software and an MCXL in his office, and he's tested this for us multiple times. So far, so good, I would say. what we send over, or let's say the STL that we produce, this does not go over automatically into InLab. I have to say that because InLab does not allow this function. What happens is when you click on export to InLab in Clinux, then InLab will open automatically. We call the software for you. And once InLab is open, InLab Cam, then you can go ahead and navigate to your case folder and the case that you were working on. And then you can take that file, whether it's an STL for milling or for printing, and you just basically import that file into InLab Cam, and you go from there. We don't have fit issues. We don't have any issues at all when it comes to InLab Cam. So I think you're going to be in good shape there. Okay. Now we do have a clarification on that first question. So the first question was, what's the best way to build up connectors? And the clarification from the doctor is connectors, crown, splint to the platform. Sorry, now I understand. Good. Doctor, I have to tell you this. I'm not a 3D printing expert. And so I would actually refer this question now into the Clinux user group. I'm going to ask this question anonymously in our Clinux user group for you. Thank you for sharing that with us. Let me just make a screenshot of your question so that I don't lose it. 1 second there. Hey. 1 second. There we go. Okay. Okay, perfect. Good. So, yeah, if that is it, if there are no other questions, I'd certainly like to thank everybody for taking the time to join us today. And yeah, as I said, please come and visit us on Clinux user group. We're going to be in there. I'm going to ask this question about the printing supports for the crowns and for the night guards. And yeah, oh, we maybe have one other question. We have a new question. Thank you for the answer. In terms of copy feature, when we exclude part of the pre-op in the copy, what does Clinux use to generate the rest of the crown? Great answer. So question, sorry. The doctor is asking when, you remember when I made the copy crown and then I moved the copy line away from the marginal ridge, the doctor is now asking, hey, how does Clinux fill in that data? And essentially that's what it is, doctor. It's not a sophisticated algorithm, but basically what we're doing is we're going from that copy line, like as you saw it on the occlusion, for example. As I drew that copy line away from the marginal ridge and more towards the center of the tooth, in the next step, when you click on next, what Clinux does is it takes basically the whole tooth up to the copy line, and then from the copy line outside the copy line down to the margin. This is just an automated algorithm that we have to connect these two lines, the copy line and the margin. Of course, we build a curve, yeah, a tooth-shaped curve when we build this surface, but it may or may not be appropriate and may or may not need some editing on your side. It certainly won't be perfect in many cases. So, but it does fill in the space and gives you something to work with. Let's put it that way. Okay, great. Well, thank you, everybody. And want you to enjoy your weekend. And last but not least, with regards to Clinux support, if you're in North America, please reach out to this friendly gentleman here on the left, Ryan Mattern. He's a really, really great operator of the Clinux software and is the head of Clinux support in North America. And Ryan came over to the IDS in Germany this spring, spent some time with us and everything. So he knows the software inside out. He's Ryan at cad-ray.com. And if you're outside of North America and you need support in Clinux, be free to reach out to Mr. Milos Gadoshev. He is the head of Clinux support outside of North America. He is Milos at cad-ray.com. We have one last question, and then we're going to call it a day. One last one. Question is, I have been having problems with the fitting of my splints. They're too loose and occlusion not balanced. They get when the patient bites. Okay, so that offhand, I would say, doctor, this is possibly two topics. First topic is the fit of the splint, and that should be snug and intimate. I mean, they should kind of snap down. And so that, what's going to happen, I tell you what we're going to do. We're going to flip over Clinux for a second, okay? And let's just open up a night guard, shall we? See if I get a night guard here somewhere. Hold on. Let's go to all cases. Let's close this one. Indication, night guard. Look at that. Okay. Oh, good. That's the one. Yeah, okay. We'll take this guy. All right. So there's a couple of things here when it comes to night guard. So first thing is, it really matters where you draw your finish line, obviously. If your finish line is, let's just go back to the guard line, okay? So the guard line or the finish line is the first thing that's going to affect the fit of your night guards. So for example, okay, here we have a finish line drawn. And, you know, when I drew this finish line, I really tried to draw it to the height of contour of each tooth, okay? So really right at the equator of each tooth, okay? Now, if, for whatever reason, I've drawn my night guard below the height of contour, okay? Like here. Here it's clearly below the night, there's no way that this is gonna go down. Well, I'm sorry, it will go down because we block out what's below here, but it will be loose, no? So how can you tighten it up? Well, one is, it really depends on how you draw this guard line. The second one is the case parameters. And so don't be afraid to go in here with the spacer and set it to a minus, okay? So I would start with, you know, if you're, yeah, well, you're obviously printing. I would start like, if they're too loose, then I would start with -20, and then I would print another one, let's say at -40, and then just check that and see if it's directionally correct, okay? Oops, cancel. I'm gonna discard that change. Now, the other issue is, and you mentioned this in your question, doctor, yeah, and they get loose when the patient bites. So so this is a really, this is a big one. Make sure, and I don't know if this is your case, doctor, to be honest with you, but as a general tip, I would say this: when you are doing a full arch for a night guard, make sure that you're getting the bite on both sides of the arch, okay? Take 2 bites. Whenever you do a full arch, take 2 bites, if at all possible, okay? Because what happens very often is if you have a bite on only one side or the other, then typically you've already got this, let's say, yeah, a wrong angulation on the occlusion. And this will, of course, wedge out that night guard within a very short period of time. I don't know if I've got a case here that shows that really well. I saw a night guard recently, or a full arch case, where the bite was really off, because the doctor, like, what means off? It means that on one side of the arch, all the contacts were like blood red. And then on the other side of the arch, you know, all the contacts were light green, you know what I mean? And so what that indicates is, and I don't know if it's this case, to be honest with you, but let's just take a look. But what that would indicate is that, yeah, it's a little bit open on one side and a little bit too compressed on the other side. And this is the disadvantage of taking just one bite. Now, this one is also a pretty balanced scan, okay? So what do I look at when I look at my scans? It's important to see, for example, that the amount of blue, red, and yellow over on this side of the arch is similar to the amount of blue, red, and yellow over on the other side of the arch. Otherwise, I have an unbalanced bite, you know, but many times I'm opening cases all day long, yeah? And so what I often see is that you've got red and yellow and blue and red and, you know, all the colors over here. And then over here, all you have is kind of light blue. Yeah, no red at all. And that tells you that the bite was taken over here on one side, but not taken again over on the other side. So when it comes to full arch, and that's always the case with splints and night guards, make sure you've got 2 bites to stabilize those contact patterns. So I hope that answers your question. We are out of time now, so our training is complete. I want to thank you all again for your time, and please, again, don't hesitate to reach out to the team with any questions that you have. Join us on the Clinux user group, post your cases, and let's talk about Clinux. Thank you all for your time again. Have a great weekend. Bye-bye.